Hi everybody, it's Miss Lorenz here. I'm going to talk about 2.5 and 2.6 for the 7th grade math curriculum. So this is all going to be about graphing proportional relationships. Remember in the last lesson we talked about what it means for a relationship to be proportional. This time we're going to talk about what it's like to look at and graph a proportional relationship. So before we start, I just want to remind you that when we have a coordinate pair, and this coordinate pair tells us where to put the point on the coordinate plane, that the first number is the x-coordinate and the second number is the y-coordinate. All right? And so I want you to take a look at this example right here. Let's just say, for example's sake, that I walk at a rate of 2 meters per second. So that means for every 1 second that I walk 2 meters. All right? So if you look down here at the graph, I have time on my x-axis and distance on my y-axis. And so I can sort of check this out because I can look that for every 1 second that I walk, so I'm just going over to the 1, I walk 2 meters. And you can see actually that there's a point right there at 1, 2, because for every 1 second I walk 2 meters. That's my rate. If I was to go ahead and plot all of those, I would end up with the line that you see right here. So the thing I want to talk about is how to find what we call the constant of proportionality. The constant of proportionality tells us how much the line goes up for every 1 it goes over. All right, so I was sort of just discussing that, right? For every 1 we go over on time, how much do we go up? Well, we go up 2, right? Because for every 1 second, I walk 2 meters. But I'm going to show you another way of calculating the constant of proportionality. We can do that by making sort of a stair step. Do you see this little like stair step right here, this like triangle? So what I did is I found 2 points on the line that I wanted to use to calculate the constant of proportionality. So I'm choosing this point right here, and you can really choose any points on the line. I would recommend you always find those points that are easy read points. In other words, they fall perfectly on a corner of the grid so you know exactly the value. All right, so I'm going to choose this point and this point, and now we're looking at how much the line goes up for every how much it goes over. All right, so let's take a look at how much it goes up. So here we're going from 2 to 10, so that's a distance of 8. And then from here we're going from 1 to 5, so that's a distance of 4. And if I take 8 divided by 4, I get 2. So you should see some connections here. My constant of proportionality is 2. If you look at my rate, it's 2 meters per second. And then when we get to the point where we're writing an equation for this line, this is what we end up with. Y equals 2x. All right, so let's talk about what it takes for a graph to be proportional. For a graph to show a proportional relationship, it must have 2 things, and it has to have both of these 2 things, not just one of them. It has to be a straight line. So let's take a look at this one. Yep, it is a straight line. And it has to pass through the origin. Remember, the origin is right here at 0, 0. And so you can see that this line does in fact pass through the origin, and it is a straight line. So this example right here is a graph of a proportional relationship. Let's take a look at this one. This one has a nice straight line, so we would say it's linear, but it's not proportional. Why? Because it doesn't pass through the origin. This one right here is proportional. Notice it's straight and it passes through the origin right here. So we would say the origin is right here. This one is not proportional. It's not straight even though it passes through the origin. All right, let's see if we can also look at a constant of proportionality for a table of values. So that's what we're looking at here. And so here we have a table of values. So when x is 0, y is 0, so we would have a point at 0, 0. When x is 0.5 or a half, x is 1/10. And so what I did here is I pulled out these points so that you could look at them as a coordinate pair. So all of these are coordinate pairs. We've got 0, 0, that's a point. A half, a tenth, that's a point. 1, 2/10, that's a point. So all of these are points on our graph. So what we want to do is we want to take a look at we want to take a look at these points to see if we can calculate the constant of proportionality. Now remember, we want to see how much does the line go up for every 1 it goes over. So we're going to take how much the line goes up, also known as the rise, and we're going to divide that by how much the line goes over, also known as the run. So when I take these coordinate pairs, and these are just some that were given as an example in your book, then we're going to look at the difference between these numbers. So I'm going to take 14/10 minus 1/10, and I get 13/10, so that's right here. That's the rise. It's the distance between the x's. And then I'm going to divide that by my distance between my x's. Sorry, did I say x's here? The distance between my y's are here, and the distance between my x's are here. So 7 and 0.5 or a half are 6.5 apart. So I'm looking at 13/10 over, that's my rise, over 6.5, and that's my run. And so I'm going to go ahead and divide that. 13/10 divided by 6.5. 6.5 can also be written as 13/2. So 13/10 divided by 13/2. So I'm going to turn that into a multiplication problem. 13/10 times 2/13. Remember, we multiply by the reciprocal. We end up with 1/5. So I know my constant of proportionality is 1/5. Take a look here. Remember, 1/5 is equal to 2/10. Look what happens. For every 1 we go up, see, this is a half, so we're going to sort of ignore that half. But for every 1 we go up, we're going up 2/10. For every 1 we go up, we're going up 2/10. And so you'll see the constant of proportionality, not just in the graph like we saw earlier, but also in a table of values like this. All right. That's a lot of information, but hopefully that gives you enough to get going on the problems you need to do for 2.5 and 2.6. Thanks, everybody.